Hello and welcome to this IBM Rhapsody session. My name is Frank, I'm a passionate Rhapsody user, trainer and coach, and love to share my experience to help you to become more effective. Today I would like to take a closer look at the UML terminology and how it's implemented in Rhapsody. If you compare the UML terminology with the Rhapsody terminology, you might discover one or the other difference or miss one or the other concept here and there. This can be very confusing for the novel Rhapsody user. For example, the UML send signal action is simply called send action in Rhapsody. And the UML term signal is not even present in Rhapsody. With this video I want to help you to gain clarity and understand the rationale for these differences, such that you can apply Rhapsody effectively. In the context of the Rhapsody user, I will therefore go into more detail today about the UML terms related to the UML message exchanges, such as message, event, trigger, receptions, which are often used synonymously, but according to the UML specification, they are clearly different and unambiguously defined. The video is dedicated to all those who have always wondered what is behind a UML call event or a message event, and the many other terms around UML messaging and notification mechanisms. Especially how and where these terms are used in Rhapsody and how they differ. For the explanation in this video, I will refer to the current and official UML specification version 2.5.1. The diagrams in this presentation are visualized in Rhapsody after importing the abstract syntax model, which can be found on the OMG website. You can find the link in the source note. Let's get to messages first. Messages are defined in the interaction package. They have their origin in the message sequence charts, called sequence diagrams in UML, which show the interaction, the message exchange between connected classifiers. This is also what the UML says in general terms to begin with. A message defines a particular communication between lifelines of an interaction. If we look further into the UML specification, we see that a message is further specified via its signature. Beside the create message, which designates the creation of lifeline objects, and the delete message, which designates termination of lifeline objects, we have in principle two types of messages: the call to an operation or the transmission and reception of a signal. In Rhapsody, the implementation is typically that a create message means the call to the constructor, and the object is created. An async signal in Rhapsody is implemented by an event or event reception on the receiver side, recognizable by the event flag, and a sync call in Rhapsody via the call to an operation on the receiver side. Destroy when the destructor is called. But if you look closely, this representation, the mapping of these messages in a sequence diagram to structural elements like classes, is not present in UML at all. The UML specification lacks this kind of consistency. What seems so obvious at first, and how it's also implemented in Rhapsody, is not defined in UML at all. In very general terms, UML simply states, a message is a communication in which a sender makes a request for either an operation call or a signal reception by a receiver. As Rhapsody user, we can imagine what an operation call is, but what is a signal? While users can very well model signals with Cameo or Enterprise Architect, the term or model element signal is nowhere present in Rhapsody. This brings us to the first question: what is a signal? According to the UML, a signal is a communication object that is transmitted. So it is what the thing that is transmitted. So behind every UML signal event or send signal action, there is an associated signal. And with a reception, it is expressed that an object of this class can receive a signal. This is also stated in the UML specification. A reception declares the classifier who is prepared to the reception of a signal. We also know the expression reception in Rhapsody. But when we add a reception to the class, not a signal, but an event is added or referred. It is thus expressed in Rhapsody that this class can receive this event. What is interesting, also behind the UML send signal action, which is simply called send action in Rhapsody, we have an associated event in Rhapsody and not a signal. The solution to the riddle is that in Rhapsody, signals are synonymous with events. That brings us to the next question. What is an event? According to UML, an event specifies the occurrence or happening. So an event is a moment when a signal is sent or an operation is called. There are different types of events. For example, a time event, expressed in Rhapsody via TM, the timeout event, or the change event, which is fired in a Rhapsody model when the value of an attribute is changed via proxy port or flow port. The UML call event is what is known as triggered operation in Rhapsody. The UML signal event simply corresponds, what a surprise, to an event in Rhapsody. This type of event can trigger effects or behavior, which is the case when the event is associated to a trigger. We are also familiar with the term trigger in Rhapsody. If you look at the features dialog of a transition, you will see the term trigger, saying that the transition is triggered by this event. This brings us to the next question. What is the definition of a trigger? According to UML, the trigger is the location where the event occurs. Beside the transition, a trigger can also be an accept event action, which is the graphical symbol that we find in a state machine and activity diagram. This is called the same in Rhapsody. As you can see, Rhapsody uses a single concept for different diagrams. Rhapsody thus takes a very pragmatic approach that ensures a consistent representation, starting with sequence diagrams, through behavioral diagrams and architecture, and forms the basis for optimized code generation. The convention that a signal is synonymous with an event simplifies modeling immensely, and is another Rhapsody key enabler for model-driven development. I hope to have given the viewer with a video clarity into the, at first sight, confusing and inconsistent appearing word coinages, but which makes perfectly sense from the specification viewpoint. That's it. I hope to see you soon again. Thank you and goodbye.